everyone. Thank you for joining us today. My name is Nguyen. I'm Technical Application Specialist at Dolomite. So today's webinar is one of series webinars we call Microfluidics 101 with Dolomite. So this webinar is delivered every last Thursday of each month along 2021. So today the topic is discovering key components chip. So we will learn about everything about the chip, how to fabricate the chip, and how to choose the right chip for the application. So let's move to the agenda today. So it will be including the presentation and demonstration, and finally we will have the Q&A section. So if you have any question, please feel free to write down your question in the question box or chat box. So we will discuss more details or question in the Q&A section. So today presentation content is including the drawer chip microfluidic and microfluidic chip with microfabrication and the chip surface coating, and finally the which chip is suitable for your application. So as we already learned about in the previous section, we have learned about the microfluidic technologies and the key application areas of the microfluidic technologies. It would be including the molecular biologies, particle and nanoparticle generation and manufacture, simulation of porous media, or continuous flow chemistry organic synthesis. So a very wide-ranging application area with the microfluidic technologies. We also learn about one of the key components for running microfluidic technologies is the microfluidic pump. So we provide a very wide range of user-friendly pumps designed specifically to manipulate fluid in microfluidic systems. So you can choose from the pressure pumps or piezoelectric pumps or peristatic pump or shrink pump to gain the best flow of your application. So today we will learn about the second key component for running microfluidic chip. So it's a set of microchannel etch or mold into materials, for example like glass or silicon or polymer such as PDMS. So the microchannels forming the microfluidic chip are connected together in order to achieve the design features. So when we talk about the fluids in everyday life, we think about cups or test tube or balloons. So it's very easy to handle. So however, in microfluidic, we have very small fluid container, for example, like a micro coffee cups. So they look like the one on the right in your screen. So they are made here glass, but you can make many different material like polymer or silicon. But Dolomite is specialized in glass. So it needs to take specific note of the small vessel. We are the world leader in glass chip fabrication, so we have developed capability to machine glass almost as easy as people can do on different materials. For example, we can cut, etch, drill, green, and polish. So this set us apart with working in this field well over 25 years. So the thing like drilling through the glass is not really trivial. So glass is a kind of brittle to work with. So we both the only companies that we found were able to do this. With the filter size, from smallest filter size of microfluidic is 1 micrometer with the microfluidic chip, with the tolerance of the 1 micrometer, and the surface roughness is 5 nanometer, and with the maximum temperature 5 degrees C and pressure over 300 bar. So with the let's talk about the microfabrication microfluidic chip. Here showing this slide showing the benefits of the glass compared to another the materials. So the simplest currents microfluidic device consists in microchannels molded in a polymer that's bonded to a flat surface, such as glass slide. So it's very easy to mold and bond on glass. So the reason for choosing the glass for our microfabrication is listed as a table. From the table, you can see the glass showing very good and excellent on characteristics like optical properties, mechanical properties, chemical compatibilities, thermal characteristics, and even though with surface coating, cost effective, reusability and durability, design flexibility compared to the polymer. So the following diagram so the basic process for use fabrication on a glass of microfluidic chip. Actually, the glass microfluidic chip fabrication is can be do with many material, but we choose in here we focus on glass microfluidic chip because, as we mentioned, it have many advantages compared to another material. So from diagram, we can see the step for glass microfluidic chip fabrication. So first, we can apply the chrome and photoresist layer to glass. And the second, after that, we expose the photoresist to UV light through the mask. And we develop the photoresist and add the chrome layer onto the photoresist. And the next step is we use the wet etching glass with the acid solution, and after that we remove the chrome resist and then clean it. Next step it can be do with the micro drills, flute hole and dice chip, and finally we do the thermally bond glass cover layer to achieve the final product. Here is some key production process. So the first key production process is wet etching. Isotropic or wet etching is used to form micro channels and micro well in glass wafer. So to create a channels, pattern a thin metal layer is first deposits on glass surface, as you can see from the right photograph. So a photolithography process is then used to create the pattern, and next step is the hydrofluoric acid is then used to add exposed glass areas. The acid etch the glass in all direction, as you can see in here, and the edge surface is very smooth, similar to a polished surface with smaller than 5 nanometer rawness. And next is the metal layers is then removed, and the resulting geometry is shown at below in here. Another key production process is including the micro drilling and dicing. So micro drilling for minimum hole size of 150 micron with core drilling with a hole size up to 20 millimeter. And we can use ultrasonic machining and powder blasting of hole for the tape side work. And then the thermal bonding is the next process for production of the microfluidic chip. So we can use room temperature bonding for device with the sensitive encapsulated compound part. We can use the thermal bonding for device with stand over than 300 bar with high pressure. And it can be done up to 1200 degrees C heat treatment capability. And next process for production is grinding and polishing. So this process including the flash polishing to the 100 micrometer substrate thickness, and the solid processing to create device with non-standard layers and thickness as well as a device with non-standard shape size. The important process for production is surface modification. So we can functionalize the hydrophobic or super high fluid coating and super metals for electrode, or for example, like we can coating with platinum or gold or silver, with a different application. So also we can do selective coating channel to achieve the selective different surface properties on the microfluidic chip. So if you have a look in right photographs, it's showing the hydrophobic coating by silanization process of the substrate. So this process is called the reversible process. So it's very easy to hydrophobic coating and reverse to the hydrophilic coating. So if you have a look in here, the photo, so it's showing the very super hydrophobic coating. It means the water droplet is located on the surface coating after coating. And it's left side image is showing the fully wet properties of the surface when we do the reverse reaction, salinization of the substrate. So we will talk more about the chip surface coating. It will as shown in this slide. So there is one thing that affects the surface tension, and that is the surface coating. So this is a glass slide, as you can see in the photo. So half of which is coated with hydrophobic coating, and the left side is fully wet. It means it's a kind of hydrophilic, and the right side so the droplet water, which means we are getting no wetting. So the contact angle differentiates between the wetting and non-wetting is showing in the bottom photograph. So this is something that can be engineered. So we can engineer microchannel chip to have ease of this event. This slide shows the surface effect. The question is, if we have half of glass of oil and half of the glass of water, so and you soak it vigorously, and it would be very difficult to tell which from the droplet and which from the bulk phase. So it may be a combination of both, which means a total mass. A large part, this problem is automatically solved with a micro scale, where we say that microfluidic offers very high specific areas, which means the surface effect dominates over the bulk volume effect. So if the vessel has coating, then we would able to do the distinguish which medias would be the droplet or the bulk solution. So this remains true on the micro scale, but we achieve much more control and reproducibility of our emulsion on the micro scale. So here we have two flow focusing junctions. So hydrophilic surface and hydrophobic surface. So on the hydrophilic surface, the waters wet the surface and the oils curves up into the bowl or the droplet. And hydrophobics, in the hydrophobics, so it kind of the opposite. So the aqueous water form a droplet, as you can see in here. So in here is we have a table showing the coating and the aqueous fluids and organic fluid with the surfactant. So with Dolomite can coat glass surface with the hydrophobic and fluorophilic function and supply a range of surfactant for each surface coating. So you can see in the tables with the chip surface coating is the hydrophilic. We can use the droplet fluid. It could be the hydrocarbon and fluorocarbon oil, for example, like dichromethane or mineral oils. And the carrier fluid should be water, is the aqueous phase. So and surfactant in the carrier is to be the hydrophilic surfactant like polyvinyl alcohol. With the hydrophobic coating, chip surface coating, the droplet fluid should be aqueous phase, is water aqueous phase. And carrier fluids is to be hydrocarbon oil like mineral oil or decane or hexane decane. And the hydrophobic surfactant could be used, for example, like span 80. With the fluorophilic coating, the droplet fluid also is is the aqueous phase, and the carrier fluid is a fluorocarbon oil because it's the coating by fluorophilic chip. And the surfactant in carrier is a kind of fluorinate surfactant. So we have the product, the fluorocer, to help the customer get the best performance during the experiment. So next, we will talk about which chip is suitable for your applications. As you know, with many different geometry of the chip design, we can do the many kind of application with microfluidic. For example, we can form slug with a size larger than junction size using the T-junction chip geometry. Or we can make a single emulsion or double emulsion, or even with the cell or the particle encapsulation by using the X-junction chip. Or we can do with more complicated the application like nanocrystallization or complex dense particles with different surface properties by using the two reagent chip geometry. So in this case, mixing two stream by complete mixing or incomplete mixing two stream, we can forming or the subsequent isolation the reagent into the droplet, and each droplet can be have the role as micro reactors, and also it can be forming particle with the different surface properties each particles. So with the Dolomite, we offer many types of kind of geometry chip. The Droplet Junction chip is one of our product which offers a wide range of the Droplet Junction chip with the different junction geometries and channel size and surface properties, which enables users to produce more than 10,000 droplets per second. So the Droplet Junction chip offer very excellent chemical resistance, which allow a broad range of the solvent and chemical to be used. And also the chip feature two separate droplet junction. As you can see in here, it's the T junction and the X junction. So it helps customers have flexibles in the application with different kind of geometry chip. We combine one chip. So another type of chip we have is a 3D flow focusing chip. So it's suitable for generating highly monodisperse droplet between 5 micrometer to 140 micrometer. So the chip carries two identical but separate flow focusing junction. So each junction has one inlet for the droplet phase fluid and two inlets for carrier phase fluid. So the unique pore structure on the outlets of the droplet forming junction create a 3D sheet flow in the droplet pin-off region. So this flow pattern is especially useful when handling viscous droplet fluid, which are otherwise liable to fall the junction surface. And this feature will allow longer droplet production time, and it can be extend the chip life. Another type of the microfluidic chip we have is two reagent drop chip. So with the two reagent droplet chip, we design for generating a droplet containing two reagents. So it's designed for wiring application, including the high output of chemistry or biomedicals or biomedical analysis of cells or genus particle formation and the polymerization of research. So it can be compatible. It's compatible with the Dolomite connector for quick, reliable fluids connection, and with very high, excellent chemical compatibility and high operating pressure up to 30 bar. The other type, the microfluidic chip with Dolomite is 5-input chip 3D. So with the 5-input chip 3D, 150 micron, it is a glass microfluidic chip device with design on layout described in the papers by Zahn, which published in 2007 with microfluidic direct formation of liposome and chondrocytes. So the new 3D pore structure enable particle precipitation to occur in the bulk of fluid with avoiding particle channel wall interaction. So the chip is particularly suitable for the controllable formation of the center laminar focus stream situated between 2 or 4 lateral anti-solvent stream, and the design allow reproducible diffuse mixing at 2 liquid interface for polymer particle nano precipitation and nano liposome cell assembly. And the circular microchannel, as you can see in here, provides adjunctions for it can be used for stable stream generation. So and it helps to generate very highly monodispersed nanoparticle with the 3 versions of the surface coating. We have hydrophilic, hydrophobic, and fluorophilic version, and it also so very excellent in chemical compatibility. Another chip is a micromixer chip. So with the micromixer chip, it's a lamination-based compact glass microfluidic device that allows rapid mixing of 2 or 3 fluid streams in each of 2 independent mixing geometry. So the chip can be used for the study of reaction kinetic or sample dilution, or it can be used for improved reaction selectivity or rapid crystallizations and nanoparticle synthesis as well. With standard chip we provide, we also provide custom chip design service, which can be help the customers because of many applications require development of new chip design, so it can take a time and very high cost if prototyping carry out in glass, and usually the user requires the ability to alter the chip design to establish the best geometry. So the prototyping is with Dolomite can be doing with the steps showing below. So the customer will describe the device requirement, and Dolomite will be design a chip and interface with the fabrication and prototype process and test and optimization. So after that, we can generate supply the device, fabricate and supply the device, and give its customer to do the application. The other option for fabrication, chip fabrication, we can do with 3D printer. We call it Fluidic Factories. So this with the Fluidic Factory, it can be it enable to rapid prototyping of chip design with the polymer chip. So without the glass chip, so we can use the polymer chip. We can prototyping polymer chip by using Fluidic serial chip with novel polymer deposition method. So the customer also is in control of the development cycle during the chip production with the 3D printers. So it means the customer can design by themselves chips geometries, and after that it can be easily prototyping by 3D printers. Well, I finished the presentation today now in here. So we will moving to a live demo with our system behind me. with the different kind of the chip I would like to introduce. After that, we can move to the Q&A section again. If you have any question during my presentation, so please write down the question in the question box. So if we can have more discussion in the Q&A section. So let's move to the live demonstration. Okay. Actually, in here, this is our simple single channel microfluidic system. So it will be including the 3 pump, and the 3 pump will be connected to the chip by using the tubing, and the chip in here located under microscope with the high-speed camera. So everything, every process which happen inside the chip geometry can be visualized by under the microscope. So the chip can be connected with the tubing by using our in here we have a connector and an interface. So we call it an interface. So with the interface in here, you can see. So the chip we design, we have a side can be fit with interface, and it's very easy to connect with the tubing using the linear connector. You can see in here. So the tubing we connect with the linear connector through with the serial to connect to the chip very quickly without any tool, using a tool. So we have different, many different type of chip, and I saw in presentation. So in here, I will show you the each chip geometries and how the chip look like, and we can see more detail in the microscope. So I will share the microscope with you as well. Sorry. Okay. So now you can see the chip under microscope. So the first chip I would like to introduce with the live demo section is the 5-input chip. So in here, the chip is located in the interface and connect with the tubing through the linear connector. And we use a 5-input chip in here for usually for nanoparticle and polymerization process. We use the deposition of the polymers with laminar flow to strip. So let's see what the chip geometry look like under the microscope. So here, okay, in microscope you can see the chip have five input channels. So with one input channel, the middle input channel is a droplet interface for interface, and 4 input channels is for the carrier phase. So the laminar flow will be generated at the chip junction in here, and this is the output channel for the product, the nanoparticles collection as well. So if you have to look more in more the magnification of the microscope, I can zoom up in here, so you can see. Yeah, it's better to see with the high when I zoom out the chip junctions area. So you can see in here the chip junction was designed as a 3D pore structure, so it can be prevent the particles deposition on the walls of the microfluidic chip channels. So it can have the increase of lifetime of the chip when by the prevent of the deposition of the particle during the running application. So this is 5 input chip. We also have a different chip is two inlet chip. In here you can see two inlet chip is for 2 reagent input application. So let's see what it looks like in microscope. Sorry. Okay. So as you can see in here, we also have 4 input channels and 1 output channels. So 2 input channel in here is for carry phase, and the 2 input channel in here is for 2 reagent different for interface. So it's for the droplet phase. So with the 2 different reagents, we can pump in with the 2 line here, and it will combine at the chip junction, and it will mix at the chip junction and create the droplet which contain the 2 reagents. In case of you want to do the application like crystallization or the genus particles the production. Another type of chip I would like to introduce here is the micromixer chip. So with the micromixer chip, it's very useful when you want to increase the output of the process with using the micromixer chip, microfluidic. So as you can see in here, it's showing the under microscope of the chip junction, chip channels. So it creates by the multiple channels, which can increase the mixing ability of the fluid during the running pass through the chip. So in here, it's the input chip areas. You can see. In here, okay, I got it. Okay, reduce the okay, so you can see from this side. So it's 3 input channels at the beginning of chip. So 2 channels we can for is used for carry phase. So and 1 channel for interface or droplet phase. So the droplet phase and carry phase will be mixed at the chip junction, and we can make up the droplet or cut the laminar stream between 2 streams. So at the mixing at the chip junction, so the 2 streams will go to the micro mixer channels, and by the geometry of the with the geometry of the micro mixer, it can have or increase the mixing ability of the 2 stream, and it can generate very fine particles with a high output production rate. So also with beside the glass chip, we also have the product from our 3D printers, as you can see in here. in here. So from here, you can see we can design the polymer chip with a different geometry and different size by using our 3D printer. We call it Fluidic Factory. So with the Fluidic Factory, you can design with the microfluidic chip with the channel with minimum channel size is from 300 micron. So it's very useful when customer want to change the application and and also to the screening to match the geometry which can be applied for the application. So with prototyping process by using 3D printers is very quick and very easy to obtain the microfluidic chip. So it's showing very many advantages for prototyping process using the 3D printers Fluidic Factory. Okay, so that's everything about the demonstration I would like to introduce today. So let's move to the Q&A section. So if you have any question, please let me know. And write your question in the chat question box. Yeah, so during waiting for the question, yeah, I would like to let you know about we are planning also webinar number 4 for next month. It will focus much more on the third key component for running microfluidics. So it's kind of we will focus on the surfactant or the emulsion stabilizers. So it will be delivered by last Thursday next month. Okay. Oh, I found one question. Okay. The question from the Sikant Saram. So what's the maximum mixing efficiency can be obtained using microfluidic chip? Well, yeah. So with the microfluidic chip, actually the mixing efficiencies, the number mixing efficiency is not clear determined with the experiment, but we can do with the micro mixer chip, we can do with the maximum flow rate maybe around 16 ml per minute. So it means you can mix very quick two reagents using micro mixer chip. So with the micro mixer chip, as you can see from this slide, okay. Well, yeah, with the micro mixer chip, so because of it have very specific mixer the structure and geometries. So the user can be obtained very quick flow rate with the micro mixer chip. So it can be yeah. So the two stream of the reagent can be mixed with the very high speed around 16 ml per minute. So it means the production rate is very high when you use. We have some information in the application note with the nanoparticles of the polymer of the liposomes when we use the micro mixer chip. So if you more interesting on the micro mixer chip property and how the mixer mixing the capabilities chip, so you can you can get this application note we publish on our website. So it can be shown on the results when we use the micro mixer chip when we produce liposome nanoparticles. Okay, I hope this is clear for your question, because also I cannot say any details of what numbers for the mixing efficiency can be obtained using microfluidic mixer chip, because it's also depending on each application. Yeah, it's very specific number depending on the specific application. So, but in general, we can achieve very high efficiencies, mixing efficiency when you use or running the micro mixers, you're running the application with micro mixer chip. Any questions? Yeah. So if you have the more questions, so please don't hesitate to contact us at the email Hanoi office at blackjay.com. So we already pinned the email through the chat box. So you can see the address of email in the chat box. Okay, so if you don't have any more questions, so yeah, I would like to close today's webinars at this time. So if you have more questions, please feel free to email to us to the emails, and I hope that we can see together again, all of you in the next webinar. We deliver on last Thursday next month. So the webinar next webinar will focus more about the surfactant when during the running microfluidic reaction. Thank you. Yeah, thank you everyone for joining today again, and I hope to see you again. Bye bye.